Section 1.5, Collecting Sample Data. When you want to determine or predict information about a population, you first have to decide how you're going to gather your information. Recall, the population is all of the individuals that we're interested in. When the data comes from the population as opposed to the samples, that means we're collecting it from everybody, every object. That's called a census. So if the data comes from the population, then that's called a census. Now, a lot of times a sample, Now a sample only contains information from some of the individuals in the population. And many times we can't get to the population. Either it's impossible, inconvenient, largely expensive, or some other barrier for us to gather information from the population. So maybe a sample is all we can get to, and that's just what we'll need to do sometimes. So if it comes from the population, it's considered a census, but many times we're just going to be able to work with a sample. There are two common ways to gather our data. One is through an observational study, and the other is through an experimental study. Now, with an observational study, all we are doing is observing. Pretty much the individuals or objects that we're studying are in their natural habitat or occurring naturally, and we're just sitting back and gathering information about how things are going, usually. And what's going on with the individuals, rather, is not affected by what we're doing. That's observational, kind of in the background. Think of it that way. With an experimental study, something is introduced and it does possibly change the behavior or the outcome of what we're looking at. So a treatment is introduced and we're looking at the possible responses to the treatment. So let's take a look at example 1 and see if we can determine the sampling technique, observational or experimental, that was used. Example A. A camera is set up at a busy intersection to see which drivers are more likely to run a red light. Out of 86 drivers who ran a red light, 41 were teens or young adults, 30 were middle-aged, and 15 were senior drivers. Okay, observational or experimental. Now, although a camera was put up, most likely the camera was pretty inconspicuous. It wasn't there as a deterrent necessarily, but more just to see what's going on. And we gathered this data just by looking. So this would be considered observational. Let's compare that to what happens in example B. The speed of drivers on a certain section of the highway was recorded for a week. Then a sign equipped with a radar gun that displayed each driver's speed was placed at the intersection. We should say it placed on the highway. And speeds were recorded for an additional week. The traffic department found there was an average decrease of 5 miles per hour per car. Okay, observational or experimental. Well, this time, even though we observed the driver's speed initially, we then introduced a treatment. We put up that sign, and many of us have seen that before. It flashes and it tells you what your speed is, and most of us will, oh, I better slow down. So that's a treatment, and it affected the behavior of the driver. So because we introduced something and then looked at the behavior again, this is considered an experimental study. Now, when we're dealing with trying to collect data from a sample, and the sample's coming from the population, there's a couple different ways we can do that. Probably the simplest and most widely used method is called the simple random sample. So if a population has N measurements, that's a capital N, then a simple random sample of N measurements, lowercase n, is taken in a way such that two things are possible. Every sample of size n has an equal chance of being selected. And 2, every member of the population has an equal chance of being included in the sample. So if we had 100 students, for example, and I want a sample of size 20. What item 1 is saying is that every grouping of 20 students is possible, equally possible. That's what that's saying. The second one, number 2, is saying that every person out of the 100 has an equal chance of being included in that group of 20, however it's picked. So that's a simple random sample, very easy and simple and most widely used. We also have just a random sample. So members from a population are selected in a way such that every individual member has an equal chance of being selected. Be careful that we don't have that second requirement that every sample of size n has an equal chance of being selected. That's gone here, so that's just a random sample. And make sure you notice the difference between those two. Then we have a couple other sampling methods that are useful, and the whole point of all these different sampling methods is to have unbiased data. We don't want data that has some type of pattern or slant to it. So we come up with methods that give us the best unbiased data possible. And here are some other methods. Stratified sampling. With this method, the population is divided into 2 or more groups, or what are called strata. Then a simple random sample is taken from within each strata. So with this sampling method, we really want to make sure that each distinct group is included in our sample. So maybe if we divide our group into male female, we're going to sample so many males and so many females because we don't want there to be a misrepresentation of either sex. And we could make strata across income levels, race, class status, any grouping like that, but we're making sure that each group is represented. Then you have systematic sampling. With this method, every nth item is included in the sample. So n meaning it can be some number. With this method, it'll be used when most of the individuals or objects in the population are relatively homogeneous, meaning they're pretty much the same except for whatever characteristic we're interested in that could differ from individual to individual. Cluster sampling is when the population is grouped into clusters, and usually the clusters occur naturally. So this is a little bit different than stratified. With stratified, we're introducing the strata. We're saying let's break our population down by sex, or let's break them down by income level, or let's break them down by class status, freshman, sophomore, junior, senior. With cluster sampling, the clusters usually, not always, but usually kind of occur naturally, some type of grouping. But once we have those clusters, clusters are randomly selected, and then every member of the cluster is included in the sample. So it's easy to confuse stratified and cluster. Make sure you notice the differences between those two. And the last one is convenience sampling. And with this method, sampling is done at the convenience of the data gatherers, but it's not the best sampling technique. Sometimes that's all you have, convenience sampling. For whatever reason, maybe the way the population is dispersed or whatever problems may arise, but this might be all you get. And the problem with it is it usually generates very biased and sometimes reliable data. Sometimes that's all that's available to you, but if possible, we try not to use convenience sampling if we don't have to. Okay, example 2. So we're going to see if we can make the distinction among all of these different sampling methods: stratified, systematic, cluster, or convenience. So let's take a look at a few situations. Example A. A tool manufacturer is producing a new tool. To check on the quality of the new product, every 50th tool is pulled and tested to ensure that it works properly. Well, that 50th should be a huge giveaway if you look back at our definitions, and that's going to fit with systematic sampling. So probably those tools that are coming off of that production line are pretty much all the same length, same height, same materials. but we're just making sure that there's no defect. So we're pulling every 50th, or it could be every 100th or every 1,000th product. So this is going to be systematic. Okay, example B. A local playhouse wants to make sure that it is bringing in shows that its patrons will enjoy. The population of regular attendees is divided into groups by age, 18 to 24, 25 to 34, 35 to 44, and so on. A random sample is then taken from each age group, and they are asked to fill out a brief survey. Okay? Well, we definitely have some grouping going on there, so it's either cluster or stratified. If we look back at our examples. To make the distinction, did we, the data gatherers, did we introduce those clusters, or did they kind of occur naturally? Well, we're making those distinctions with the ages. We could have done them a different way, but we're introducing those. Also, the difference you'll notice is we're sampling within each age group, but we're not sampling everybody in each age group. So this one fits with stratified sampling. We introduce the different strata or groupings, and we're sampling within each group or strata. So that's stratified. Example C. Shoppers exiting a grocery store are asked their opinion of a mayoral candidate running for office. I think this one's pretty obvious. This is convenience. And think about what would happen if you're asking people coming out of a grocery store. Usually people who shop at one particular grocery store all kind of have the same income level because they live in the same neighborhood, similar, not exactly the same, but they have a lot of things that are already the same. So you might not necessarily be getting a broad representation of the population. So maybe that's all that's available. Maybe a phone survey would be too expensive or time consuming. So this is what's being done instead, but it probably will not yield the best results. Example D. To assist a national testing agency, a mathematics department agrees to administer a set of test questions to a sample of students currently enrolled in mathematics courses. The department will randomly select 3 of its 68 sections and give the test to each enrolled student. So you've probably guessed this one since we've gone through a lot of the other ones, but I just want to point out how we make the distinction that this is stratified or clustered. Well, the classes kind of occur naturally. We didn't have to introduce and say how we're going to divide up our individuals. We already had classes that were already arranged. We're sampling the number of classes, and then within each class that we sample, every member of the class will be asked to take the test. So because every member in the class that's selected is included in the sample, that gives it away that it's cluster. So be really careful. Convenient kind of sticks out. That one's relatively obvious to recognize, and systematic is rather obvious because you're usually going to have that number that pops out every 100th, every 1,000, something like that. But between systematic, or rather between stratified and cluster, can get a little confusing because both of them are grouping, but it depends on how the groups are introduced and whether we're sampling within the group or we're sampling the groups but including everybody within the group. So make sure you get that straight in your head, but you want to learn all of these different sampling techniques.